Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Munder, first lecture in object-oriented analysis and design. This lecture will cover part of learning outcome number one, which gives you an introduction about some of the concepts in object analysis and design. So in this lecture, we will try to define the meaning of object. We'll try to see the difference between procedural language and object-oriented programming language. We'll see some of the elements in object-oriented analysis and design, which are minor and major elements, and we also explain the link between class and object and how the relationship will be explained between a class and object. So the first thing that we need to know, what is the meaning of an object? Everything around you actually is considering an object. If you look around you everywhere, you're sitting or anywhere, everything considered as an object, like a table, like a chair, like a mug, a coffee, a house, a room, everything, even your computer and everything. These are down here as an example of an object, and each object will have a data and operation. These data is some of the characteristic of that object. For example, if we say a table, we say the table is blue, has four legs, circular. All these things are properties that describe the object, that describe exactly the state of the objects. And we have an operation which basically a behavior or action that can be done by the object. So if we say, for example, we have a car, the operation of the car is move forward or move backward or stop. It's more like a verb. All right. So object is in computer programming is a self-sufficient entity that has its own data and its own operation, identifying him from other objects. So if we say object orientation, that means we're thinking about everything as an object. So we can say that a computer program is basically a collection of objects, okay, instead of saying it's a collection of data and operation, because these data and operation are included in each object. So any program is a collection of objects if we are thinking about object orientation programming. These are some of the examples that demonstrate the object. So we have an object. This object will have a data and will have an operations. For example, we have an object called bank account. This data or the attributes are balance and number, which has a value, but we have some operation which define the behavior of an object, like deposit and draw, same as the person. We have two person here. As you can see, they both have the same operation, walk and run, because almost the same object, but they are different in the values here. So they are totally different objects because the values here are different. So they are not the same object because the values here are different. These are some of the sample on object. So think about everything as an object, okay, the data or the variable inside the object, I say we call them sometime what? We call them attributes, or we call them variables, or we call them what? Data. This is the first thing. The second thing is that the operation inside the object, we call them sometime methods, we call them sometime functions, we call them sometime behavior. What we call them? Behavior. I'm gonna write it on the American way, behavior. So it is just a behavior of an object. These are the names of the object, content. So we think about the object as a noun, and we have to add that before it. It's just a standard way. So for example, we have the time, the date, the bank account, the car, the person, the student, the class, and so on. So it has to be a noun, all right? But if we say think about the behavior or the method of an object, it should be what? It should be a verb. So the object name should be a noun, and you could add that before it, okay? And the behavior or the method or the method, it should be what? It should be as a verb, like walk, run, stop, move, and so on. Okay. Now, these are explaining the diagram below, explaining some of the characteristics of an object. For example, it describes the object state. For example, we say car can be 4W or salon, for example. All right. Let me just delete this one. Yeah. Sorry for that. So yeah, erase all ends. So the car could have what? Could have a 4W, or could be a salon. All right, like a type of it. A phone could be a black or white, so it's a color. All right. So TV could be a plasma TV or LCD TV. This is just the size of the TV, and could be 4-inch or 60-inch. So these attributes like a color or weight or size, they are more like characteristics or attributes of the objects, or we call them sometime in the class variables of that object. But if you look at the behavior of an object, they come as a verb, so the phone can ring, right? Things that the object can do. The phone can do the ringing. The chair can move. A car can drive, and something more like a verb, right? It describes behavior are specific to objects. Behavior are specific to object. But now the attribute describe the state of an object. Always, what is the state of an object? What is the current state? Say the table is circular and red table. So we describe here the state of the object. Now, if you have a system and you have more than one object in your system, we say that we have a group of objects. This is the object number 1, the object number 2, object number 3, and so on. They need to collaborate with each other. They need to collaborate with each other in order for the system to work. And they collaborate with each other by exchanging message, or by calling what? A method. So there will be a method here, okay, and for this object to interact with this object, he need to call what? He need to call the method inside that object. So they interact with each other by two ways: by exchanging a message, or by invoking or calling a method in the other object. For example, here if I have two object, employee, if I have an employee object, sorry, if I have an employee object, all right, and the employee has salary, okay, if I wanted to collaborate with the employee and print out its salary, I call the method called get salary to print out the method. So I collaborate with the object employee by calling the method get salary. This is just a simple example. All right, so now we know that what is the object. Everything is around you is an object. Each object has attributes or data or variables, describe it, and also has an operation, or we call them methods, or we call them behavior, that describe what this object can do exactly. All right, this is an example of a person. This is, for example, an object of a person. Okay, this object has a hair color, has a tall, height, weight, and a name. Okay, but also this object is can walk. So it is a method. It is what? A method. It is a method. This one is an attribute. Ahmad is a name, is an attribute, but walking is what? Is a method that this object can do. Right. I'll just give you an activity for you to just look around you in your room, or wherever you're sitting in the class, or anywhere around you, and try to identify three at least objects, and for each object try to identify three attributes. I'll give you an example. I'm sitting here in the class, so I'll say I will choose an object called table. This is the object I choose. Two attributes for the tables are the size of the table, and the shape of the table, number of legs. All right, we can choose, for example, attribute for the table, clean, or we can say fold the table, like folding the table. So this is an example for you. Try to do the same, and list three objectives and list two attributes for this objective and two operations that object can do. All right, for object orientation, now, as we can see, as a software developer, we need to design the software and then develop it. So when you design the software, okay, you try to simulate the software similar to the actual real world. All right. Now, when you do the implementation, there always will be a space or a difference. Your system will not be exactly the same as the real world. So we call this difference is a gap, semantic gap. In a procedural language, the semantic gap is very big, quite big. As you can see here, is quite big. This is the semantic gap. In our work, we need to what? We need to try to make the semantic gap small as much as we can. All right. But if you use object-oriented system, that you will see that the gap or the semantic gap between the real world and the actual implementation of the system is a little bit quite small than in the procedural language. It could be like 95% similarities. Somehow we are trying to reduce the semantic gap size, so somehow the implementation will look more like the real world. All right, so I need you to understand here what's the meaning of semantic gap and what's the purpose of reducing the semantic gaps, and which better in reducing the semantic gap, procedural language or object-oriented language. This is one of the advantages of object-oriented programming language over other traditional programming languages. So what is a procedural language and what is object-oriented diagram? Now, procedural language, I'll give you a snapshot in a procedural language. Procedural language is basically your program has a list of instruction that should be executed step by step. Now the program will be divided into methods, or we call them functions. The method will be and functions, and the design should be like top down, like you go 1, 2, 3, 4, and so on. You cannot jump from one place to another place. It has to be from the top down. And we do a procedure call. We do what? A procedure code. This is why the code is very complex, and sometimes the code will be repeated to do the same thing again and again, and you cannot reuse the code because it's just a procedure in this program. It is part of this program. I can't reuse it again. This is less secure because the data has no access modifier. It's just the data in a function, or you can declare it in the whole program so all the function can use it, and this will make the data less secure and anyone can access it. But if you look at the object-oriented programming, trying to solve the problem based on what? Based on the concept of objects. So the program will be divided into small parts. They are called what? Objects. Okay, and there's some protection for each object. There's the data has to have level of access. They use, for example, private, public, protected. If you learn Java or C, C++ or C Sharp, you recognize when we use private, when we use what? Public, and so on, to specify the level of access to the data inside the objects. The design is a little bit complex. Okay, the design, not the code. The design is a little bit complex, but because we are using objects and each object is independent from the other objects, so we can reuse the code in any object. We can easily communicate between these objects using method call or exchange message. It is more secure because the data has each object has a boundary. Each object has a boundary and everything is reserved inside the object. If anyone wants to access anything inside the object, he need to have an access with permission from the same object. So the focus in the design is on object. This is the difference between procedural language, and object-oriented programming language. Now, there's more, explanation on the difference between them. Now, as you said, that the organization structure that procedural language goes from the top to down because it just go into a flow. But object-oriented program is more like objects, and there's a collaboration between them. So it's just a network. It is not like a tree that you need to climb or something like that. For the protection, we say that procedural language has less protection because there is no access modifier in it. But object-oriented programming is more protection because each object has a boundary and its data and its operation inside it, and it need an access level to access these data or operation inside that object. Now, it is easy in object-oriented programming to modify the software because it follow the principle of object-oriented programming. Each object is independent, and if you change one object or replace it with another object, that will not affect the system. But in procedural languages, we have software, and if you want to change something, you have to look at the whole program. So it is a little bit more expensive and need more time, and it is not easy to change. We can reuse some of the codes in object-oriented programming anywhere in the same program or in other programs. But in a procedural language, the only way to reuse the code is to copy and paste the code. So this is repetition and a waste of time. The configuration is more costly in procedural language than object-oriented program because it is just a sequence of code and so on. But for the object-oriented programming, they follow like object-oriented principle. We'll study this principle. You can just remove an object, and these objects are independent, but they collaborate with each other. So the configuration is not that cost, and there's no risk in configuring the object-oriented programming or changing the configuration in any special cases. Now, this is an example of procedural language. As you can see, they just go from the top to the down in a sequence steps. Sometimes they use if statement, or they use in a programming language, they use switch to choose like two paths or something like that. So they use switch statement or if statement like here to choose between two different paths. This is the only way, but they still what? They still top down approach. This is the start, this is the end. All right, this is normal traditional procedural languages. Now, for object-oriented programming language, you can create the code, the class, which is basically an object of code. There's a block in the objects, but for the interface, you can create any interface you want. A graphical interface, you can change the interface without changing the code. You can change the code and the interface is still there. So you still can modify the code without affecting the interface, and you can change the interface without changing the code because they are independent from each other. This is the difference between object-oriented programming and procedural or traditional diagram or programming. So why we use object-oriented programming? It's obvious for you after this comparison that why we use object-oriented programming, because now most of the language are following object-oriented programming. Even the database, even the software development, everything is using what? Object-oriented, because it's easy, modular, easy to update, easy to understand, not that complex, and so most of the language will use it. If you want to have more information about why we use object-oriented programming and the difference between procedural and object-oriented diagram, there's a link here for the videos that explain something in an easy way. Try to look at this video and give you an overview and review of the information that we have already explained. Okay, now in object-oriented programming, to implement the system and to design the system, we use what? We use UML, which is called Unified Modeling Language. We will study this language in Chapter 2. This language has a number of diagrams. We can use them, for example, for the behavior, we use, for example, use case, we use activity diagram, we use sequence diagram. For the structure of the system, we use system organization, class diagram, object diagram, and so on. I know probably you'll never hear about this, maybe, but we'll practice this in the next chapter. So just an an in small introduction on what's coming in the next chapter. Okay, this is, we call it UML. Remember that we will use this to design and the system. All right, we talk about what is object. Now let's see the difference or the relationship between object and class, because we have a class in the program. How do we treat the object and how we create the object and in the coding and so on? All right. Now object and classes are really linked to each other. They are, they are in a relationship. You cannot have an object without a class. You cannot have a class without dealing with an object. As you can see in C or C Sharp or C++ or Java or any other languages, you create what? You create a class, and this class will represent the object. So these two, class and object, are basically the foundation of object-oriented paradigm or object-oriented system programming. Okay, now the object could be really exist as a physical exist, as we say the table is really exist, you can touch it, or it could be a logical, represent like a process or represent a project or represent a logical thing. So the object could be logical or physical thing, to make the system easy. But for the class is only logical concept. Always logical concept. The class is always logical concept. All right. And now the class represent a collection of an object. And now if you have a similar object, you can group them into one class. I'll give you an example, like shapes. Okay, like shapes. What do we have? Like an example of shapes. So we have rectangle, we have triangle, okay, we have circle, we have a lot of shapes. They're all shapes, are they? Yes, they're all shapes. So we create a class called shape, and these are objects. They are similar to each other somehow because they are all shapes, and we group them into one class called shapes. So this is why we say a class represents a collection of objects. Okay, these objects should have the same characteristic and same behavior. So each of them, most of them has, we calculate the area, most of them has a length and so on. Yes, this is an example of an employee object. Employee object include all kinds of employees, like a guard, manager, supervisor, secretary, and so on. So all these employees they are common in number. They have a number, they have a name, they have salary, they have department, they have address, and these methods are common in all the employees. So we group these objects, the employees object, in a class called employee. Something uh, like an example of a class is represent a collection of an object, where object having the same characteristic and they exhibit common behavior. All right, we talk about now classes and objects and the difference between classes and object. I'll stop here, and the next section I will explain the principle object-oriented programming. So far we have identified what is the meaning of an object and what is the link between object and a class, and the difference between programming in a procedural paradigm or an object-oriented paradigm. I'll see you in the next section, inshallah.